Hello everyone, I'm Hassan Yusuf. Today my presentation topic is object-oriented programming and we'll discuss about Java. There are 4 principles in object-oriented programming. Just like Java, there are encapsulation, inheritance, polymorphism, and abstraction. We'll discuss about all 4 principles. At first, we're going to talk about encapsulation. In this mechanism, the encapsulation binds all the codes and the data together and keep both safe from outside of interface and misses. In the object-oriented programming, encapsulation refers to the building of data and that operate the data easily, or the restricting or direct access to some of an object's components. Encapsulation is used to hide the values or state of a structured data object inside a class, preventing unauthorized parties direct access to them. Publicly accessible methods are generally provided in the class to access the values, and other client classes call these methods to retrieve and modify the values within the object. This mechanism is not unique to OOP. Implementations of abstraction data types offers a similar form of encapsulation that similarly has been explained by programming languages theorists in the term of existential types. The authors of design patterns discuss the tensions between inheritance and encapsulation at length and state that their experience designers oversee interface. They claim that inheritance often breaks encapsulation, given that inheritance exposes a subclass to the details of its parent's implementation, as described to the problem otherwise of inheritance, and therefore encapsulation can become too complicated and hard to debug. Inheritance: the processes by which one object acquires the properties of another object. What is inheritance in object-oriented programming? Inheritance is the procedure in which one class inherits the attributes and methods of another class. The class whose properties and methods are inherited is known as parent class, and the class that inherits the properties from the parent class is called the child class. The inheriting thing is along with the inherited properties and methods. A child class can have its own parent properties and methods. Inheritance is a mechanism where derive a class from another class for a hierarchy of classes that share a set of attributes and method. Polymorphism: this is one interface and multiple methods. Polymorphism is one of the core concepts in OOP languages like Java, Python, and others. It describes the concept that diverse classes can be used with the same interface. Each of these classes can provide its own implementation of the interface. In Java supports 2 kinds of polymorphism that can overload a method with different steps of parameters. This is called static polymorphism because the compiler statically binds the method call to the specific method. Within an interface in hierarchy, a subclass can override the method of its subclass. If you instance the subclass, the JVM or Java Virtual Machine will always call the overridden method. Even if you cast the subclass to its superclass, that is called dynamic polymorphism. Abstraction. Abstraction is a process of hiding the implementation details and showing only functionality to use the user. Ways to achieve abstraction that are abstract a class and interface. Abstraction is the key concept of OOP. Its main goal to handle complexity by hiding unnecessary details from the user. That enables the user to implement more complex logic on the top of the provided abstraction. Without understand or even thinking about all the hidden complexity, that's a very generic concept that's not limited to the object-oriented concept programming. We can find it everywhere, also in real world. Objects in the OP languages that provide an abstraction that hides all the internal implementation details. Similar to the copy machine, that's in a real life example, just need to know which methods of the subject are variable or available to call and which input parameters that need to trigger a specific operation, but don't need to understand how this method is implemented and which kind of action it has to perform to create the accepted result. Let's implement an example in Java. Some other object of programming languages, the syntax might be a little bit different, but the general concept is same. Interface in Java. An interface in Java programming is a blueprint of a class. It has static constants, abstraction constants. An interface is a reference type in Java. It's similar to class. It has a collection of abstracted methods. A class implemented an interface, thereby inheriting a method, the abstract methods of the interface. Along with abstracted methods, an interface may also contain constants, default method, static methods, and nested types. Method bodies exist only default methods and static methods. Writing an interface is similar to writing a class, but a class describes the attributes and behaviors of an object, and an interface contains behaviors that a class implements. Unless the class that implements the interface is abstract, all the methods of the interface need to be defined in class. An interface is similar to a class in the following ways. An interface can contain any number in method. An interface is written in a file with a .java extension with the name of the interface matching the name of the file. The bytecode of an interface appears in a class. The class name is .class file. Interface appears in packages and their corresponding bytecode file must be in a directory structure that matches the package name. However, an interface is different from a class in several ways, including cannot instantiate and instantiate a interface. An interface doesn't contain any constructors. All of the methods in an interface are abstract. An interface cannot contain instance fields. The only fields that can appear in an interface must be declared, both static and final. An interface is not extended by a class, it's implemented by a class. An interface can extend multiple interfaces. Reasons to use an interface: achieve fully abstraction, to support the functionality of multiple interface, that inheritance, to achieve losing of coupling. The relation between classes and interfaces. A class extends another class. An interface extends another interface, but a class implements another interface. Exception and expectation handling. Exception is an abnormal condition. In Java, expectation is an event that disrupts the normal flow of the programming. It's an object which is thrown at runtime. Example: arithmetic expression, null point expression, number format exception, etc. And the purpose we use to handle those exception, that called exception handling. We use 5 keywords to handle exception handling in Java. There are try, catch, throw, and throws. Here is an example of exception handling. So here is our all over overview in OOP that we are using at Java. Thank you.